This is crazy. I don't know it.
Julia, we have a softball game tomorrow. We have to practice.
I'm not allowed to play softball unless I know this problem.
Okay, so if you play softball with me and you get the pitch right, then I'll teach you how to do the problem.
Done deal, you're on.
Now, the basics you should know is that correlations are statistics that show how variables are related to each other.
Two variables, mostly. So, Leah, can you explain to me now what a positive and negative correlation really is?
Okay. Positive correlations is a slope that is between r equals 1 and being the most positive, and r equals 0 being neutral.
Oh, I get it now. So, what would r equals positive 0.5?
So, r equals positive 0.5 would look like this. R equals 0.5 would be a positive correlation where the points are not completely in a straight line, but are at the same time not completely scattered. It's in the middle of the two.
Oh, I understand it now. So what does r equals negative 0.3 mean?
So r equals negative 0.3 is when the points are scattered farther apart, so it's harder to tell what the graph and slope is saying.
So this is what it looks like.
R equals negative 0.3. Although it is spread out, you can still tell in which direction it is negatively pointing, and it's still condensed enough to tell its correlation.
Great! I understand this. It's getting so much easier.
And there's also zero correlations, or an undefined correlation, which will be R equals 0. This is because you are unable to tell whether the correlations are positive or negative. Like so! Okay, so I hope I've been able to help you out, but I'm kind of confused myself about what the correlation coefficient is.
Oh, that's the one thing I know. Correlation coefficient is a number that represents how close the points are together. So, for example, 0.5.
Oh, so the 0.5 would be the correlation coefficient. The coefficient is between negative 1 and positive 1. The numbers in between are to show that the graph may not seem perfectly positive or negative, so you can scale out your answer. Do you understand?
Actually, yeah.
And to make it even clearer, I'll give you a real-life example. A real-life example of a chart that can be seen as a correlation is the one below. Right. The positive one would be positive because positive correlations are between two quantities and occur when an increase in one quantity is related to an increase in another quantity.
Oh.
That's so easy, right?
Yeah.
And this negative correlation is a negative correlation because negative correlations occur between two quantities when an increase in one quantity is related to a decrease in another.
Oh, it's so easy.
Like decrease, negative, increase, positive.
Correlation. That's correlation coefficient, positive, negative, and 0. Thanks for watching. Here's our next one. So, direct variation. What is it? Variation is y equals ax. Ordered pair given is 3 and 9. To write and graph a direct variation solution. Once given the ordered pair, replace y equals ax for the correct number. For example, if the ordered pair given is 3 and 9, this is how you'd set it up. 3 equals x, and 9 equals y. Replace each number with the variable. 9 equals 3x.
Oh, I get it. Because the 3 is the x and the 9 is the y, and the problem is y equals ax, you would substitute the 9y for the y and the 3 for the x.
What you do is you don't want the x there because you want to find the answer. So you divide them by 3 to get the 3a without the 3 because you want to have something equals each other. So your answer, the answer will then be y equals 3x. 0, go up 3 and over 1 and you put a dot there. You keep going with that same thing and then you make a line to see your graph.